Section 4 is about inscribed angles. So an inscribed angle is an angle where the vertex is on the circle. So like this angle here, we have the vertex is at point E on the circle, and then it extends to the other side of the circle. So this is the inscribed angle. The intercepted arc is the arc that is formed by the sides of the angle. So from D to F there would be an intercepted arc. And it's said to subtend the angle. So when you say that an arc, or it could be a chord, subtends an angle, it just means that its endpoints are on the angle. The measure of an inscribed angle is half of the measure of the intercepted arc. So if my angle is 50 degrees, that means the arc measure is 100 degrees, or vice versa. So here, if angle SRU is 40 degrees, that means that arc SU would be double that. It's going to be 80 degrees. And then if we know that arc RT is 120 degrees, if we follow that back to the inscribed angle RST, back here, this is going to be half of that. So half of 120 would be 60 degrees. So the inscribed angle is half of the measure of the arc. If you have different inscribed angles, but they all end at the same endpoints on the circle, like these three angles here, then those angles are going to be congruent. So if they open up to the same spot, that means that they are equal. If you have an inscribed angle that is going to be 90 degrees, then that means that the arc is a semicircle. It's going to be 180 degrees, so it forms a semicircle. This diameter that's a dotted line here, this is showing where the semicircle is. So if you know that you have a diameter of the circle, you see that it goes through the center, then the angle that opens up to that is going to be 90 degrees. So here, for example, because we have a diameter of the circle, it crosses through the center of the circle, that means that this angle is going to be 90 degrees. So I'm just going to do 4x plus 6 equals 90, and I'm going to solve this for x, so I would subtract 6, giving me 84, and when you divide by 4 then you get x equals 21. So x would equal 21 here because this angle is going to be 90 degrees since it opens up into a diameter of the circle, creates a semicircle there. Here I have two angles that open up to the same endpoints on the circle. So they both open up to C. So I have ABC and I have ADC. Because they open up to the same spot, that means that those two angles are going to be equal. So we have 10y minus 28 is equal to 7y minus 1. So I'm going to add 28 to both sides. That gives me 10y is equal to 7y. This would be plus 27 now. Negative 1 plus 28 would be 27. So subtract 7y to get the y's. On the left-hand side, we'd have 3y equals 27. Divide by 3, you're going to get y equals 9. So if y equals 9, now I can go back, plug that into ADC. I have 7 times 9, that's going to be 63. Minus 1 is 62. So angle ADC is 62 degrees. If you have a quadrilateral that's inscribed in the circle, so remember, inscribed just means it's inside the circle, that the endpoints touch the circle and the shape is inside the circle. The opposite angles are going to be supplementary. So remember, supplementary means that they add to 180 degrees. So in our case here, A and C would add up to 180, and B and D would also be supplementary. So let's look at an example. I have a quadrilateral, a four-sided figure, inscribed in the circle, so my opposite angles are going to be supplementary. That means that 3x plus 25, if I add that, so that's this angle up here, if I add that to the 6x plus 20, those two angles added together should equal 180 degrees. I'm going to combine like terms, so 3x plus 6x would be 9x, 25 plus 20 is 45. If you subtract 45 from both sides, that's going to leave you with 135. When you divide by 9, you get x equals 15. Now our job was not to find x, it was to find each angle of the quadrilateral. So I'm going to go back and plug that in. So here, if I do 3 times 15, that's going to be 45 plus 25, that gives me 70. Down here, 6 times 15 is 90, plus 20 is going to be 110. And this is good, this verifies what we were doing here. 70 plus 110 does equal 180 like it was supposed to, so that's good. If I plug in to this other angle over here, 10 times 15 would give me 150. When I subtract 69, that's going to give me 81 degrees. And then this final angle, in order to get that, it should be supplementary to the 81 degrees here. Opposite angles add up to 180. So I'm just doing 180 minus 81, and that is going to equal 99 degrees. So in a quadrilateral that's inscribed in the circle, so that means each vertex touches the circle, inside the circle, opposite angles are going to be supplementary. They're going to add up to 180. When you're looking at the inscribed angles, if you have two angles that open up to the same spot, those angles are equal. If your angle opens up to a diameter of the circle, that angle is 90 degrees. And then when you're looking at the inscribed angle compared to the intercepted arc here, the angle is going to be half of the arc.